This video is the notes for after the first homework check. We're going to be talking about pyramids and cones. So you can follow along on your packet and just fill in as we go. If it goes too fast, you can pause. I'm going to add in some commentary and stuff, but this will give you a chance to do things on your own pace. So we talked about pyramids at the beginning. Pyramids, the difference between a pyramid and a prism is that pyramids have triangular faces. So you have 4 triangles or 5 triangles or 3 triangles, and they all are at the common vertex. Okay, and you notice that this just says a polygon. There's a difference between a regular pyramid and a non-regular pyramid. We'll talk about that. The altitude of the pyramid is the height, and that is right here at this right angle. I think you can see that arrow moving on the video. I haven't done this for a while. A regular pyramid, which is mostly what we'll work with. Regular means it has a regular polygon for a base. So it has a square or an equilateral triangle. All the sides are equal. Okay, and the next definition is a slant height. Exactly what it looks like. It's right there. We often call it L. And a slant height means that we're talking about the height of one of these sides. If you laid this flat, it'd be the height of that triangle. So we're talking about this space right in here. So regular height is ground to the top point, and slant height is the same thing but up the side there. So a cone has some similar terms, and it has a circular base, obviously, and the height of the slant height of the cone similar to the pyramids. But you might want to notice there's a right triangle here, so you could do a little Pythagorean theorem if you wanted to. You might need to sometimes. So r squared plus h squared equals L squared. So you do have right angle. That will come important later on when we're finding some stuff. Okay, so you're going to switch over to the back of the paper that you have. And sorry, at the bottom of the front of this paper, and we're going to fill in just some of the details here. So looking at this, this is has a square base. So it's a square pyramid. And again, this is the shape that's on there. You're going to need to write these things in yourself. The height. Well, the height needs to be the vertical distance to the middle here. We don't have that height. We have the slant height. The slant height is 9.3. You can write that in. We don't have this height, but we can do a little Pythagorean theorem action to figure that out. So I have this little right triangle here, which that is 2.5. It's halfway across. 2.5 squared plus the height squared equals 9.3 squared. And so sometimes you actually have to go and find the height. And if you can find these missing parts, you can do any of the formulas. So while you might want to pause the video, pick up your calculator, and get a height that's 8.96, somewhere in there. It depends on what the rounding is. And the height will be used in different ways. Sometimes you have different formulas for area and volume, and sometimes it's the slant height. So just making sure you understand that that's the slant height. They're not the same as the height. The height and the slant height cannot be the same. The height has to be smaller than the slant height. So the net, we're good at nets, so I'm not worried about you there. But I want you to see why. Whoa. On the net, later on when we get to our area formula. So basically you have 4 triangles and the 1 square versus your other shapes had 2 bases. This only has 1. Okay, go to the next shape. Look at the base. The base is a square. Again, we have the slant height. We would need to find the height. So this is 5. I could do Pythagorean theorem. 5 squared plus h squared. I'm writing with a mouse here. It's kind of crazy. Equals 13 squared. So h equals 12. We know the slant height, so we got that, 13. It's a square pyramid. I'll let you draw the net. Next one, the base is a triangle. So this is a triangular pyramid. There's an equilateral triangle here. So differences would be the net is going to be a triangle with triangles coming off of it. So this middle part is the base. This is kind of a funky angle. Looks like they're giving us the slant height as 10, and one side is 6. So we have 3. This one's a little bit more complicated to find the regular height. If you look at this is the base. We're inside of this, and we would need to find this to figure that out. Well, that is a little complicated question. We're not actually going to have to find the height on this one right now. But seeing that this is not equal to 3 going right there, that's not equal to 3, you can see it's not all the way across. Yeah, the slant height is 10. The name is a triangular pyramid. This is a rectangular pyramid. It's not regular. Something to note. So if you were making a net, you would want to note that 2 of the triangles are definitely bigger than the other 2. Because their base, one of the bases is 10, one of the bases is 4. And then you have cone, slant height 5, regular height. We'd have to do Pythagorean theorem right here. You're going to see a lot of triples coming up. 3 squared plus, getting bad on the mouse there, height squared equals 5 squared. Trying to write with that thing. So the height would be equal to 4. Again, notice the difference between height and slant height. Otherwise, when we get to this other stuff, it's going to be plugging things in. We tried to draw cone nets before. We know it's a circle, but then you have this kind of weird pie shaped, like somebody took a chunk out of pie. You don't have to be able to make an accurate one. That looks like Pac-Man. Okay, so that's the end of the basic sketching there. Now I'm going to give you notes on the surface area on the next video.